Now let's have a look at logical operators. So logical operators are basically and, or, not, which means that they are used at places where boolean values are there. So for example, true and true, or you can have true or true. And earlier we gave an example of unary operator not, which means that if you put not in front of any boolean value, then its value is flipped. Okay, so this is what I was talking about. So if you print something like not true, then this will be false, it flips the value. So you see that it is false, and if I print not false, then it is going to be true. Okay, so and there is something called and or. Now logical operators are like sort of they will always have boolean values, and sometimes they might not have boolean values as their arguments, and we will see what happens soon. That, but for now, for simplicity, let's see that their arguments, left side and right side, will be boolean values. Okay, and when that is the case, then their answer, the final expression, will also be boolean value. Now again, when one of the values are not boolean, then how to evaluate and what will be the final expression, that we will see later. For now, when all the arguments of these logical operators, the left side, right side, everything is boolean, then the final value is also boolean. Now you see, what is and? And you might have seen in your undergrad courses also, right? And the whole and expression is true when all the values, all the arguments are true. So here, true and true, this will be true. Why? Because both the operands are true. However, true and false, one is true and another is false, so no, both are not true, and that's why this whole expression answer will evaluate to false. And this is this can be generalized to any number of ands, or for that matter ors, we'll see later. So true and true and true, everything, if everything is true, then the whole expression will be true. If any one of them, let's say here, here, or here, if or more than one also, it at least even one of them is false, then the whole expression will be false. Okay, so among and expression, if the whole, and this does not need to be, this does not need to be exactly true or false. You can write an expression which evaluates to true and false. So for example, if I write uh, 2 is less than 3 and 5 is less than 8, you see this thing is true and this thing is true, both are true. So actually this is evaluating to true, this is evaluating to true, ultimately it is coming out to be true and true, and that's why the answer will be true. Okay, because both the arguments are true. If any one of them is false, so for example, let's say here I say that 15 is less than 8, this is false. This side, the left side is now true, but right side is false, and that's why if any one of them is false, then the whole expression is false, and that's why it is false. However, that is not the case in or. In or, what happens that among all the arguments, if even one of them is true, then the whole is true, whole expression value is true, otherwise it is false. So true or false. Now one of them, you can see that here is true, and that's why this expression is true. You can see here that both are false, none of, at least one of them should be true, then it will be true. Here all are false, and that's why the expression is false. In this case, you see that true or true or true, obviously everything is true. If I just need one true, but here everything is true, then obviously it will be true. But in this case, you see that false or true, at least one thing is true, and that's why it is true. If it would have been false or false or false, then it will be false. Here at least one of them is true, and that's why expression is coming out to be true. And as we discussed, not just flips the values. Okay, just now I mentioned that you don't need true or false exactly. You can have other operators which evaluate to true. So here in this case, you can see that a is 5, 5 is greater than 2, which is false, 5 is less than 10, which is true, and true, which means that this will be false, and this will be true. The 5 is greater than 2 is true. Okay, this 5 is greater than 2, this is true, and 5 is less than 10, that is also true. Okay, so true and true and true, and that's why it is going to be true. Here what is happening, and first of all, why it is true? Because every value has to be true. Here all the three values are true, and that's why it is true. In this case, what is happening is that a is greater than 2. Yeah, this is true. And a 5 is less than 10. That is also true. And true. Again, whatever single logical operator is there, but whatever the both arguments are there, both are true, and that's why the expression is coming out to be true. And we'll see that same thing will apply with or also. In or, just the case is that we don't need everything to be true, just one of them should be true. That will be fine. So here okay, I don't need to look at other cases. This one is true, so obviously everything will be true. Now here we don't have exact value, so we have to see the value. So 5 is less than 2. 5 is less than 2 is definitely false, but 5 is less than 10 is true, and that's why one of them is true, and that's why it is true. Now 5 is less than, again this is false, but 5 is less than or equal to 5. You understand, less than or equal to, either it is less than or equal to. If any one of them is true, then this expression is true. So in this case 5 and 5 are equal, and that's why this expression is true, and this left expression is false. That's why false or true. What is that? True, because any one of them has to be true. And but here we see that okay, 5 is strictly less than 5. This is false, and this 5 is less than 2 is obviously false. So false or false, none of them is true, and that's why the whole expression is false. Okay. And now we are going to see some food for thought, that okay, what is happening here is that I am having and or, both of them in a single expression. So what will this evaluate to? This will be first evaluated, then the answer will be evaluated with or what will, or firstly this will be evaluated and then this. Secondly, here also you can see that okay, and or and, what do you think? Firstly this and will be executed, this and will be executed, and then finally or will be executed, or I will do this or first, and whatever the expression will come, that will be ended with this and this, which means this and this whole expression, whatever the final value, and this. So what is the grouping? What is the grouping? Okay. Now let's try it out rather than seeing this. So let's see this exact statement. So a is what? A is 5. Okay, so 5 is less than 2, and 5 is less than 8. Okay, so you see, let's try that out. 5 is less than 2 and 5 is less than 8. 5 is less than 2 and 5 is less than 8. Okay, and then I will do or after or I have 5 less than 6 and or 5 less than 6 and 5 less than 10. 5 less than 10. Okay, so first of all, let's see what is this value. This thing is true. Okay, now let's try to answer it in two cases. Okay, first case, what we will do is that we will group this thing first, or we will group first. Okay, and in the second case, so you understand, here we were not grouping anything, we were just at the mercy of the ordering whatever the precedence is there, but here we are specifically grouping. And that's why I told you that whenever you are in doubt, why to, and you don't remember the precedence, then why to bother? Just group in whatever way you want your code to behave, just spit it out in that way, in the form of grouping. Okay, so now you see that the first one is false and the second one is true, and when I did not do any grouping, then I got true, which means that actually when I don't do any grouping, then the behavior is like the second one, which means that firstly and is happening both sides, and then the final answers we get, and then we do all of that. It shows us that and has higher precedence than or. We just verified this, but to be frank, this is actually already there in the operator precedence. So these logical and logical or logical not, these things I intentionally left earlier because I did not discuss these operators earlier. Now we find the proper places for them. So the proper place for logical and is just above assignment. So you can understand it like just before assignment, in the end you will do the logical operations of and or. and not will be like whenever you can see that unary negation, you give a priority, right? At that point of time, do the priority, give the priority to logical not also, which means that if I have a complicated expression, something like which involves less than, equal to, and all those things. So less than, so let's say 2 is less than 3, equal to 4 is greater than 9 or something like that, right? And there is an and then let's say 4 is less than 8, or 4 or 2 is greater than 7, something like this is written, let's say. Now you understand that how these things are working. First of all, you have to see that less than, greater than, firstly they will be resolved, right? Which means that grouping will be firstly like this, firstly this will be done, this will be done, right, and this will be done, right, and then this will be done. Okay, that is fine. Now we see that, okay, first of all, don't never use double equal to, always use triple equal to. Okay, now we are seeing that we are doing equality and not equality, which means that after that this and or will not be executed. Firstly this whole thing, I am putting a larger bracket, this whole thing will be executed, right? And then finally and or are going to be executed, but among them also what is going to be executed first? Firstly and then or, which means that firstly these whole things will be executed, whatever answer will come. I'm just bracketing, but you can understand. You just do firstly evaluate this, and then whatever the answer comes, that will be odd with this thing. So you understand? So if you like for example multiplication and addition, like these are very simple, right? So if you are very much confident about the precedence, then just no need to keep brackets. But otherwise either you have to be accustomed to this operator precedence, or you can look it up. You can just do a bit of googling there, let's say JavaScript operator precedence, and then you can see, and then you can go through the table if you don't remember anything. So you can see that here all the tables are, and there are many more operators which I have not discussed, but slowly we will discuss many of them. But the point is that you can have a look here and then see that what is. Anyways, whenever in doubt, use brackets as a simple rule, right? So just as an example, if this thing is there, just now we saw in console also that firstly and is done, and then or is done. So this green one is the correct ordering. This ordering is not correct, because and has a higher precedence than or. Secondly, again let's say you are using simply and or on these boolean values, false or false and true. So again firstly false and true, this thing will be evaluated, and then this thing will be evaluated. Okay, the answer might be same in both cases, but actually what is happening internally is firstly and is happening and then or is happening. In some cases answer will not be same. For example, here if you do or first, then answer will be different. Here firstly you do and first, then answer will be different, and the correct answer is when you do and first. Okay, so that would be all for now. Next we will look at truthy and falsy values in the next video.